Okay, so we've got a situation. The string shown vibrates up and down 45 complete cycles in 10 seconds. It asks you to determine the frequency, period, wavelength, and speed. This is a standing wave, yeah? This is like what you saw out in the hall yesterday. We were shaking that string, or that slinky. Who was doing that? Was that you? Yeah. And we saw these things here. We saw these things here. Should we label them real quick? Go ahead and write this down again in your notes or in the in your warm-up problem, wherever that is. Let's write down what we know. Do y'all remember what these things are called here? It's frozen. It's unfrozen. What are those things called? Antinodes, yeah. And do you remember what these things are called here? Nodes. Did I tell you the trick of how to remember them? No. Well, it's true. So anti is going to be the opposite, right? But you got to remember one of them. Nodes, the word nodes means no movement. Okay, so you can keep that in your brain that nodes means no movement. That's the place on the wave, on the medium that is not moving. They are at rest. Okay, so you got nodes and you got antinodes. We've got a length of 6 meters. It wants to know the frequency, period, wavelength, and speed. Where are you going to start with this? Where did you start with it? Go for it. Okay. Antinodes?
Yeah.
Okay. Okay. Did you guys catch what he said? So you're saying that the wavelength is 2 because there are 3 antinodes and there's a 6 meter length in there. So my quick question for you, because that like the logic of that makes sense to me. Where does one cycle end? I want you to watch, because remember that when Quentin was doing this, it wasn't like the slinky split in half, right? So it was actually moving, like this was moving a whole lot. So from here, tell me when to stop when we've made it through one complete cycle. Watching carefully. I'm tracing the wave. Does it stop there? Is that one cycle? Tell me when I get to one cycle. That was not very resounding. I heard a few people say stop really quietly. But yes, this is the place where we stop. So this is one complete cycle. Let's draw it on here. If you haven't done this yet, go ahead and do it with your pencil or your marker or your whatever it is too. This is one complete cycle. That means that this distance right here is one wavelength. So I like your thinking, like your thought process, but we got to do it a little bit further, don't we? Yeah. So help me out then. If that's one wavelength, it goes from here, oops, I'm gonna draw it up here, from here to there, how far is the wavelength? 4? Is that making sense? If from equilibrium to equilibrium is 2, that was the logic that Augustine had a minute ago, right? So 2, 4, 6. We're doing 2 of them, so it's going to be 4 meters. So the wavelength of this wave is indeed 4 meters. It's really important when you're looking at a standing wave that you look at a complete cycle, right? So you can go from one antinode to over, or from equilibrium. You just have to make sure you go all the way through an entire cycle, okay? All right, so the wavelength is 4 meters. Done. We got some more to do. What else you got? Got wavelength done. Check. We had frequency, period, and speed. Reading the question is often important. I don't mean this in like a, I'm not saying you didn't, but just making sure you see this. It says here that the string vibrates up and down 45 cycles in 10 seconds. Think about those units. What is that really telling you? 45 cycles in 10 seconds. What kind of a value is that? I'll give you a hint. It's either the frequency, period, or speed. It's, so what'd you say? Is it the period? Why did you say? Okay. So period is time for one cycle. I'm going to write this down. Friends, I would encourage you to as well. So period is the time for one cycle. Measured in what? What are the units for period? Seconds. Let's define these other things since we're here. What's frequency? If you don't know, get out your green sheet right now and look. It's measured in hertz. It says it right there. Yeah, it's measured in hertz. Frequency is measured in hertz. What is frequency? Do not rely on this middle table. Get out your green sheet right now. The big note sheet that we worked on for a lot of days, okay? You have to know where to find things. Look on the green sheet. It's on the back of it at the top. No, this one here. Your note sheet. Your note sheet. What is frequency? Number of vibrations per second. Vibrations could also be cycles. If I were you, I'd write this down right now as well. If I were you, I'd write this down right now. If you didn't know it off the top of your head, this is why we're doing this. We're reviewing it so it gets in your brain. I know it. I want you to as well. Okay? Frequency is the number of vibrations per second. Period is the time per cycle. Hey, what's speed? Velocity of the speed? Or, yeah, the speed. Yeah. How fast the wave or the energy travels? What are the units for that? Meters per second. All right. Now we've got definitions for these things. Look carefully at this thing highlighted in blue. I'm going to give you 30 seconds to talk to your table. You need to figure it out. What is that 45 complete cycles in 10 seconds? What does that represent? Go, go, go. Have a conversation right now. What did you decide? 45 cycles in 10 seconds. 45 cycles in 10 seconds. What is that a measure of, friends? It's a measure of frequency, isn't it? Yeah. That is a frequency. Is that in hertz? 45? Would I say the frequency is 45? No, what would I say the frequency is? 4.5, yeah. 45 divided by 10? Yeah. All right, 2 down. Oops, I did that in orange. I meant to do it in purple. Oops, you get the idea. All right. I'm going to give you 1 minute at your table right now to figure out both the period and the speed. This is all 7.2 stuff. This is all stuff that you should know. Okay? Do it real fast. Right now, go, go. Let's do it. All right. How do you find the period? 1 over F. It's true. I'm doing these in opposite colors. I'm sorry if that is confusing to you. But the period is equal to 1 over F. 1 over 4.5. You plug that into your calculator, right? What'd you get? 0.22. There's your period. And then how do you do speed? Wavelength times frequency, right? V is equal to F times lambda. So I've got a frequency of 4.5. I've got a wavelength of 4 meters times 4.5 hertz gives you a velocity of 18 meters per second. Fantastic. All right. Friends, that took us a lot longer than I anticipated. That implies to me that we've got a lot of work to do still. Okay? Let me tell you the plan for the day today, going forward. Okay? We kind of got this standing wave stuff figured out. You know what a node is, you know what an antinode is. Okay? We're going to quick do I'm going to just run through to make sure you understand the lab. Half of you are going to do data collection today, half of you do it tomorrow, and the other half is going to work on some 7.3 practice, part of which is more problems like the one we just did. Okay? So don't tell me you can't do it, because you for sure can. Okay? For those of you that are going to work on the lab, you are going to choose a research question. So it may not be the same one. You're going to draw a research question, I should say. It may not be the same one that you wrote about in your design. That's okay. All right? These are the 3 different research questions that are possible. You need to make sure to write your research question down on your data table. Everybody needs a data table. Okay? If you are working on the problems, then you'll get your quizzes back from Mr. B, and then you'll also work on some practice. I need you all to listen real quick. Please stop talking. If you know that you will be gone tomorrow, then you need to make sure that you're in the lab group with me, and we'll split that up in just a minute. If you know that you will be gone tomorrow, make sure that you pick up the 7.3 practice sheet as well, so that you have this to take home with you over break. Okay? If you know that you will be gone tomorrow when you take your data, if you would like to do the conclusion evaluation today before you go, like before you leave school, let me know and we can do that. I've got them all printed and ready to go. It'll take you 15 minutes, okay? And regardless of if you're going to be gone tomorrow or not, if we indeed do not have classes after spring break, check your email. I don't mean that in a like, maybe I will, maybe I won't. Yes, you need to. Yes, there is an expectation, okay? So check your email and I'll tell you what the expectation is. Maybe it's nothing, maybe it's a lot, but I will let you know then, okay? But you're not off the hook if you're not here tomorrow is what I'm trying to say, all right? If you know that you're not gonna be here tomorrow, come up here, please. Everybody else just stay in your seat for a second and we will get you divided up in just a moment.